All right, folks, good Wednesday morning to you. We're going to do our best to quickly knock out Chapter 16, Section 1 today. This right here is the back of, or the second sheet of the notes for Chapter 16, Section 1. I did post those on Monday's classroom assignment. If you were able to print them out, or again, you don't have to print them out, but they're there if you wanted them. All right, so the end of chapter 16, section 1 has to do with the pH scale, okay? Now, we have already looked at the pH scale when we talked about indicators and we talked about how to easily find if something's acid, base, or neutral. The first thing about the pH scale is that it is a number range, and it ranges from 0 to 14. Okay, that's the first thing that we want to get down, is that the pH scale ranges from 0 to 14. pH, the kind of one way to describe pH, just like a common way to, I guess, describe it is hydrogen power. pH measures the power of hydrogen that a solution has. That's a really simplistic, common way to say it. Here's the textbook definition, and the textbook definition doesn't seem like it's very helpful in any way, but once you see it, you'll see that actually it does help a little bit. It's kind of a weird definition. pH is the negative of the common logarithm, math stuff, of the concentration of hydronium. Okay, weird definition. You look about what in the world is that supposed to mean? Well, pH, the numbers that you get for pH, basically is a reflection of the concentration of hydronium in a solution. So the concentration of hydronium is important to help you figure out what the pH is, okay? That is a weird definition, negative of the common logarithm of concentration of hydronium. Folks, that definition, as strange as it is telling you how to solve for it, how to calculate pH. It's telling you how to do it. So pH, the equation for pH, first it's the negative, okay, first part of the definition, common logarithm. Hopefully you know from math and from your calculator, the abbreviation for logarithm is log. Okay, you've got a button on your calculator that says log, negative log concentration H3O plus. So to find the pH of a solution, you take the negative log of its concentration of hydronium. And obviously, I hope it's obvious to you, you do need the concentration of hydronium to calculate. So the stuff that we've done the past couple of days with KW, that's why we did that first. Sometimes you have to calculate H3O plus, and then you can calculate the pH. So they go hand in hand. All right, we have pH. We also have POH. Very uncommon. Most people have never heard of POH, but because you can also measure or calculate how much hydroxide there is in a solution, you can do POH. The definition is exactly the same as this one, except it is the negative of the common logarithm, not of H3O plus, but of hydroxide. Okay, so it's the same concept. It's just dealing with hydroxide. But, you know, over time, as acids and bases have been worked with, hydronium and hydrogen are kind of the big deal. They're easier to measure and that kind of thing. The equipment that we use, pH probes, pH meters, things like that, they're geared towards picking up hydronium and hydrogen. Okay, the equation is exactly the same, negative log, except it's for OH negative. Okay, so those are two very simple equations. It is literally just typing the right buttons in your calculator, and we're going to get to that in a minute. I'm going to go ahead and get through all of the notes as quickly as I can, and then take you to a couple of practice problems, okay? Now, here's a real helpful, this next dot, this is a really super helpful piece of information. The sum of pH and POH of a neutral solution at 25 degrees Celsius, room temperature, average room temperature, pH plus POH equals 14. That is a super helpful piece of information though. pH plus POH equals 14. That is a time saver. It makes some problems so much easier, just knowing that right there. All right, just like we had some relationships between hydronium and hydroxide, that tell you if something's acidic, basic, or neutral. We have that with pH and pOH. You can just look at their values to tell if something is acidic, basic, or neutral. All right, hopefully you'd pick up that if they're equal, that would mean the solution is neutral. Okay, and for example, water, the pH is 7 and the pOH is 7 as well, based off of the amount of hydronium that's present. So because they're equal, that would be a neutral solution. Now, you have to remember, pH less than 7 is acidic, okay? pH less than 7 is acidic. So if the pH value is less than the pOH value, the solution is acidic. Because if the pH is less than pOH, like if the pH is 5, well, remember, we have this relationship up here, pH plus pOH equals 14. Well, I can very easily find the pOH, 14 minus 5, which is 9. Okay, so if the pH is less than the pOH, the pH is going to be less than 7. All right, that's the only way the pH can be less than the pOH is if the pH is less than 7. So that makes it acidic. All right, and then to remember, if the pH is greater than 7, then the solution is basic. All right, so once again, oh, I didn't write it down. If the pH is greater than the pOH, the solution is going to be basic. And just like with the one above, say the pH is about 10. The pH is 10. So if I go over here, remember the two of them added together is 14. 14 minus 10 is 4. So the only way that the pH can be greater than the pOH is if it's greater than 7. So pH greater than pOH is basic, just relationship stuff, just knowing the numbers. And in my opinion, this right here and this right here is so much easier to remember than these two dots. If you can just remember how the pH scale works with less than 7 being acidic, 7 being neutral, greater than 7 being basic, pH is the one we're familiar with. pH is the one that we know. And so it's easier to work with, okay? Again, we're going to practice this in just a second. The very last thing in section 1 is right here. You can find H3O plus and OH from a pH or a pOH value. Now, we've already seen how to find H3O plus and OH, hydronium and hydroxide. We have already seen how to solve for them using KW, and that is a great equation to use. Real simple. It's division, basically. But you can use rearrangements of these two equations to find H3O plus and OH as well. They're going to look kind of weird, and I'm going to show you how easy it is to do on your calculator in just a minute. But here's what they look like. To find H3O plus, you take what's called the antilog. It's real easy to do on your calculator. I'm going to show you in a second. You take the antilog of the negative pH value. You do that, you've got H3O plus. For hydroxide, you take the antilog of the negative pOH value, okay? So these look so strange. I know these look so ridiculously strange, but they're super easy to do on your calculator. Very easy to do on your calculator. All right, so I'm going to show you just how easy these are to do on your calculator. All right, what we'll do is at least one example problem for each of, we just got through 4 equations. We just did 4 equations in a couple minutes, okay? So we're going to do at least one example of each problem, okay? I may do one more, but we'll see. All right, so let's see. I'm going to write down my equations up here. I've got pH equals negative log hydronium. We've got pOH equals negative log hydroxide. We've got hydronium equals antilog negative pH. And we've got hydroxide equals antilog negative pOH. Again, these are super easy to put in your calculator. Okay, you'll see it's just pushing buttons. That's all this is about. All right, so let's see. For the first one, we want to find the pH. That's what we're looking for. And we have the concentration of hydronium as, let's see, 4.2 4.5 times 10 to the minus 4. Okay, so this is the information that we have, and now we need to solve the problem. So just like we've done all year long with everything, we're going to write the equation first. So pH equals negative log hydronium. That's where I'm going to start. Now I'm going to go plug in. Negative log into H3O plus, I'm going to plug in the value. 4.5 times 10 to the minus 4. Now here, it really doesn't matter if you put the M or not, and you'll see why in just a second. Okay, how easy this is to plug into your calculator. Okay, now here's the trick though. Right now, my calculator is in scientific mode. I don't want it to be in scientific mode. So remember, you can just hit on and clear, and it clears your memory. And that gets rid of scientific. But why? Why, Ms. Torbett? Why don't we want it to be in scientific? All this KW stuff that we've been doing has had these in scientific. Well, let me show you why. It goes back to this right here. The pH scale values are from 0 to 14. These are regular old numbers. We don't want those to be in scientific because they don't need to be. They're regular numbers. So we just want those to be 0 to 14. So when you're finding a P, pH, POH, just regular old numbers is all we need. Okay, so how to type this in? Real easy. You are going to type in this exactly the way it looks into your calculator. So watch what I do here. Let me scoot this up so you can see all my buttons. Okay, so negative. Here's my little negative button right here. I don't want the subtraction button. That's subtraction. I just want my negative button. Negative. Okay, there's the first part. Now, log. You look right here, L-O-G, big letters under the second button, log. Okay, so right now it looks exactly like what I wrote on my paper. Okay, now I've got to type that number in, 4.5, second E for times 10, negative 4. And I'm going to close those parentheses. It looks, with the exception of the E, it looks exactly like what I wrote on my paper. Then I just hit enter. And voila, there's my pH. Okay. Now, there are actually significant figure rules for pH and things like that. I don't spend time on that with y'all. All I'm going to tell you is that I always like for you to go to 2 decimal places on your pH. You're going to have a whole number in the front and then 2 more decimal places. So we would record this pH as 3.35. Okay, 3.35. So that's the pH of this solution. All right, now remember, the pH scale is 0 to 14. This falls between 0 and 14, so we're in good shape. That's the pH. Okay, now I didn't write it down, but let's tell if this solution is acidic, basic, or neutral. And this should be really easy because you know this. You learned this in middle school. We talked about it earlier. This is a pH less than 7. So it is acidic. Okay, because it's pH less than 7, it's acidic. That's fine in pH. All right, let's look at another one. This one, we are going to find the POH. This one's going to have a slight twist to it. Slight twist. Now, in our notes over here, where'd my notes go? In our notes over here, oh, I didn't write it down. I should have written it down. To find POH, I neglected to write this down earlier. You do technically need the hydroxide concentration to calculate because hydroxide's in the equation. But there's other ways you can do it as well. So let me show you that. All right, in this one, I'm not going to give you the hydroxide. I'm going to give you the hydronium again. You might be thinking, why in the world are you doing that, Ms. Torbett? That doesn't make any sense. Okay, but you'll see. You'll see why I'm doing this. Okay. All right, notice I gave you the exact same hydronium concentration as in number 1. I'm like, well, but I'm going to write down the equation, POH equals negative log hydroxide. And you're like, but why? That doesn't fit. I'm supposed to have OH. That's true. A lot of pH problems, a lot of chapter 16, section 1 problems are multi-layered, meaning there's multiple things you got to do for you to be able to get to the answer. Now, there's really 2 ways that you could go about doing this one. Okay, and thankfully we've done number 1 already, and that's one way. One thing that you could do is from the H3O plus, you could solve for hydroxide using that good old KW equation. Okay, there's that KW equation from the past 2 days. I can go plug in my values. like so, and I can find hydroxide, which comes out to be, I'm just going ahead and writing it down because I'm trying to do this quickly. I know that these videos are taking longer than I would like for them to, but you know, this stuff takes time. All right, so typing that in, that's my amount of hydroxide. So then once I find my hydroxide, then I can actually use the POH equation, plug in the hydroxide that I solved for. So I will do that for you right here. I'm going to go negative log 2.2 second E negative 11. And it shows me that my POH out to 2 decimal places is 10.66. All right, so there's my POH. That's one way to do it. And that's a little bit longer way. And you'll see why here in just a second. Because the other thing I could have done is what we did in number 1. I could have done my pH equation. And I could have found, I'm not going to redo it because it's right there, could have found that the pH is 3.35. And then I could have remembered that pH plus POH is 14. There's where that is so helpful. So I could have said, all right, well, POH is 14 minus 3.35. And it's not going to be exactly the same as what I just did right there. 10.65. I'm off by a 100th place, but it's good. It's good enough. Okay. So I like to show you one like that because there's multiple things that could happen. You could be asked for one particular thing and be given something that doesn't directly take you to it. Like up here, H3O plus directly takes you to pH. But on one like this, I can't go directly from this to that. I'm going to have to change this to something else that can then get me to the thing that they're asking me for. And that's something that I find kind of neat about chapter 16. It's like a puzzle. It's trying to figure out all the puzzle pieces and where do they go and how do I get from point A to point B by going off this little side road here, because that's what's happened here. Point A to point B. I can't do that straight. So I had to take a little side road. I had to have a little diversion and go do that. And these are kind of neat that way. All right, so that's finding pH and POH. You can either plug straight in. You just really have to pay attention to what's given to you. Is what's given to me directly related to the equation, like it was up here? If it's not, you got to find your way to it. Okay. All right, real quick, let's get a couple more in. Okay, next one. Okay, we want to find H3O plus. That's what we're looking for. And we have been given a pH of 12.70. Oh, I forgot. Let me come back up here. Forgot to do it on this one. Let's look and see if number 2 is acidic, basic, or neutral. Let's see if we can figure that out. Okay, well, I have POH here. We had already found the pH. We already know that this is less than 7. So this one would also have to be acidic because the pH is less than 7. If you had not gone that route and you had gone straight to the POH, what I tend to do, me personally, because I cannot keep the POH information in my head. It just does not stick. I always convert to pH. I always find pH because I know the pH still. So we would find that that was acidic. But in this case, POH is greater than pH, so it's going to be acidic. Okay, there were multiple ways that we could have looked at that. All right, here we go. This is just, both of these are just going to be straight plugging into the calculator. And again, you're going to see it's just pushing the right buttons. Okay, there's the equation. I'm going to plug in my numbers. And now I'm going to show you how to do this on your calculator. Now, on this, we do want anything in brackets to be in scientific notation. Okay, we just came from pH, which is not in scientific notation. And now we're going to the things in brackets that need to be in scientific notation. You just got to slow down and pay attention. All right, so how to type this in your calculator, really easy. Anti-log is second log. Okay, second log, that's it. Second log, that's anti-log. That 10 raised to the something is anti-log. Then I'm going to hit my negative button, not the subtraction button, but my negative button, and then 12.7. I'm going to close my parentheses. Now, it did happen to give it to me in scientific notation, but if I hadn't been in scientific mode, I would have gone to scientific mode. We're going to do 2 significant figures just to stay consistent with the way everything has looked. So all of that's going to round up to 2.0. 2.0 times 10 to the negative 13. And because it is concentration, it's going to have an M. I didn't mention that above. pH is just a number. Okay, pH and pOH are just numbers. They do not have units, no units on them. They're just numbers between 0 and 14. But those square brackets means concentration. So we got to have the M on it again. All right, before I forget, let's see if we are acidic, basic, or neutral. Okay, again, we've got the pH. That's the easiest way to go. pH is greater than 7. Greater than 7 means that it's basic. Okay. All right, last one, and then I'll talk to you about one more thing that I haven't talked to you about yet, and then you'll be off to your classroom assignment. Okay, last one, we're going to do the exact same thing, except this one's for OH. It's going to work the same way. On this one, we're going to have a pOH of 13.14. Okay, pOH of 13.14. Real simple, nothing extra going on. We just got to change the equation to show that it's OH and pOH. I go to plug them in, negative 13.14. All right, again, we'll come over here. Antilog is second log, super easy, second log, negative 13.14. Okay, again, it came out in scientific notation for me already. 2 significant figures, so we're going to be 7.2 times 10 to the negative 14. 7.2 times 10 to the negative 14. And because it's square brackets, that's going to be M. All right, again, let's see if this is acidic, basic, or neutral. So like I said, I like to go to pH, but I don't have pH. I have pOH. So I'm going to find pH because it's super easy. 14 minus 13.14. This is going to be a very small number. 14 minus 13.1, whoops. 14 minus 13.14 is 0.86. That is a pH way less than 7. So this is most definitely acidic. Very, very, very acidic. Okay. Something I want to point out to you about your numbers very quickly. And again, I apologize for these going on as long as they do, but it takes time to get this stuff to you. All right, I just want to show you something that can kind of help you know, is my answer like even remotely close? Let's take a look. Here's the concentration of hydronium. Its exponent is 4. The pH is 3.35. That's pretty close. It's ballpark range. That's close to 4. If I look here, hydroxide, I'm coming down to this one. Hydroxide, the exponent is 11. The pOH was 10.66. They're super close. When you're looking back and forth between a concentration and a P, the exponent and the P are going to be super close. They have to be within 1. Okay, they have to be within 1 of each other. That's one way that you know that you've typed everything in right. I'll look down here. Here was my pH. My exponent was 13. They're very close to each other, so I know that that's right. I'll look down here. My pOH was 13. My exponent was 14. They're within 1 of each other. That's how you know that you've done it correctly. That's how you know that you're okay. All right, because they're going to, your exponent value and your P value are going to be within 1 of each other. And that's how you know that you've typed everything in right and that it's done the way that it's supposed to be done. Okay, I know that that is super fast, and obviously we would be taking a whole lot more time with this stuff if we had it, but we don't. So you're going to hop on over to Classroom now and do, again, another multiple choice Google Forms assignment. And then that'll do it for section 1. Tomorrow we will do the beginning of section 3. And then we'll take Monday and Tuesday of next week to kind of wrap up section 3 as needed. If we're able to get done on Tuesday, then I'll find probably one more little Edpuzzle video for you on Wednesday. But like I said, we will wrap everything up a week from today. Next Wednesday, we'll be finished. As always, if you have any questions, any issues, just send me a message and have a good one.